Good morning, sir.
Yes, good morning, students. Going to study about the Schrodinger time independent and time dependent wave equation. Okay, so before that, let us have some look about the classical mechanics. So we have studied in the previous classes. This classical mechanics will be applicable to those particles which are observable things that we can see from our eyes. But when it comes to the matter of atom, so atom is what? Is the smallest particle, which is indivisible particle. So what it consists of? It consists of proton, neutron and electron revolving around it. So when it comes to about the velocity of the electron or the momentum of the electron, the classical mechanics is failed to explain about this phenomenon. Alright. So that time the new thing has came into the physics, that is quantum mechanics. Quantum mechanics. So what inadequacy we got in case of classical mechanics is this theory is unable to explain the behavior of the light. So as we know that light is a particle or light is an wave nature, so there is lot of controversy was going on. So as per the the Newton's, so everyone knows, those who have studied physics, yeah. So we know the Newton's laws. So we have 3 Newton's laws. So first law, according to the first law, what it is? Law of inertia. So every body continues to be in the state of motion or rest until unless an external force you apply it. But this law is only applicable to the celestial bodies, just like you can talk in about universe, about our earth or moon, any other planet in the universe. For that it is applicable. And the second law is law of force, F equals to ma. So the mass into acceleration is nothing but gives rise to force, right? So and the Newton's third law is every action there is an equivalent opposite reaction. There is 3 laws are there. There's all laws will come under the classical mechanics. Right. Whenever the quantum mechanics will come, the great scientist name will come, that is, what's its name? Albert Einstein. The name it is Albert Einstein. He has given the revolutionary change in the physics, that he has brought the quantum mechanics picture. Alright. So now we'll move to our topic. So what the controversy we had? So in classical mechanics, it is unable to explain the behavior nature of the light, right? So as I am telling, light is behaving like an particle nature and light is behaving like an wave nature, right? There is 2 nature is there. So Newton's corpuscular theory, first Newton's corpuscular theory, Huygens wave theory. So according to the Newton's corpuscular theory, light is an particle nature, right? And according to the Huygens wave theory, light is an wave nature. So there was lot of fighting was going on. So how come this light is behave like, how come this light, can we say somebody is telling that it is a wave, somebody is telling that it is a particle. There was a lot of dishum was going on between the scientists. One scientist is telling no, it is wave. One scientist is telling no, it is particle. If you are telling a particle nature, then you should be able to explain all the phenomena which having the light. Example, from the particle nature we can easily explain photoelectric effect. But from the wave nature, we cannot explain the photoelectric effect. From the wave nature, we can explain about the diffraction phenomena. Diffraction phenomena, when the light is going like this, so light will come out. So by using the wave nature, we can explain diffraction phenomena, we can explain the interference of light, polarization, like that, but we cannot explain the photoelectric effect or Compton effect. So no a single scientist is able to explain these phenomena with describing light as a single thing, or wave or particle. So these are different aspects of the light. So no scientist was able to explain. So in that, meanwhile, the great scientist, that is, did you heard this name? De Broglie has came into the picture, that he has given a great hypothesis. Hypothesis means there will be no proof available, only that is an imagination thing according to him. So he has given one hypothesis that sometime light behaves like a wave nature and sometime light behave like an particle nature, that is called dual nature of light. So for this hypothesis, he got Nobel Prize in the physics. So anybody can tell something, it will not be given directly a Nobel Prize. So a lot of research has done, and it has proved that light behaves like a particle nature and wave nature. So Davison and Germer, two scientists, they have did the experiment and they showed that it is a particle nature, and one more is this gamma ray microscope experiment, from that wave nature has been proved. After getting proof, he got a Nobel Prize for this hypothesis. So we'll come to our topic, that is wave nature and particle nature. So light behaves like a wave nature as well as particle nature, so dual nature. So when it will behave like a wave and when it will behave like a particle, so most important to think about it. Yes, when the light is emitting or absorbing or emitting, it behaves like an particle nature. When the light is propagating, it behaves like an wave nature. Understood? When light is emitting or absorbing, it behaves like an particle nature. When light is propagating, it behaves like an wave nature, travel with the speed of 3 into 10 to the power of 8 meter per second. So the speed of the light is 3 into 10 to the power of 8 meter per second. So how much far it is? If you imagine, so physics is nothing but you have to keep imagine in your mind, this much speed means how much long it is. So if you remember, this much speed means if the earth is there, it can travel 8 times in 1 second, right? So it can travel our whole earth 8 times in 1 second. That is the speed of light, right? So it is too much speed, we cannot imagine also that much far it will move. So that is the velocity of light. So this has been given by de Broglie hypothesis. He has cleared the doubt between the particle and wave nature, right? Understood? Shall we move to our topic, that is Schrodinger wave equation? Okay, right. Before that, a small thing about the wave we'll study. We'll study about the what is meant by wave, that is matter wave. This has been given by de Broglie. The wave associated with a matter particle, the wave associated with a matter particle is called matter waves. So the wave which is associated with any particle, that we call it as matter waves. So this has been given by de Broglie, and the wavelength of this matter wave is lambda is equals to h by mv. H upon mv. Here H is Planck's constant. H is Planck's constant, whose value is 6.626 into 10 to the power of minus 34 joule second. And m is mass of the body. Yes, m is mass of the body, and v is velocity of the body. Body we can take as a particle, or the small particle we can take as a particle. So the wavelength which is associated with a moving particle is given by lambda is equals to h upon mv. So how he has proved this one? De Broglie has given the hypothetical expression like this. So how he has proved that one? So according to the Planck's energy relation, we have E equals to, what is that formula? E is equals to h nu. Here h is the Planck's constant and nu is the frequency. This is for the energy relation according to the Planck's. Yes. So according to the Albert Einstein, so h nu can be written as, can be written as h c by lambda. Nu is equals to c by lambda. Yes. You can write, if you want, you can write on the reason this nu equals to c upon the lambda. Okay, according to the Albert Einstein, so according to the Einstein mass energy relation is E equals to mc square, right? E equals to mc square. So that is, mass can be converted into energy and energy can be converted into a mass. So make it equation number 1, equation number 2. Now equate the equation number 1 and 2. So equating equation 1 and 2, we get, so equation 1 we can write hc by lambda, or we can write this mc square equals to hc by lambda. So this c we can cut. So this implies that mc equals to h by lambda. So lambda equals to h by mc. So here de Broglie hypothesis is applicable to the small particle, not with the velocity of the light. It is applicable to the particle which velocity is lesser than light. So for that reason we can take lambda equals to h upon mv. That is the velocity of that particle. So if you are taking the c, it is the velocity of the light. So that means lambda equals to h upon p also we can write. Okay. So this is the proof has been given by the matter waves by the de Broglie. Right?